friends, welcome to Brave Solution Times. For today's video, we are going to see how to solve example 1.4 and 1.5. So let's get into the video. Example 1.4. If A is a non-singular matrix of odd order, prove that determinant of adjoint A is positive. So here they have given A is a non-singular matrix of odd order. Okay, so it's an odd number, and then prove that determinant of adjoint A is positive. Okay, so what the given thing is, A is non-singular. So this is the first thing they have given, non-singular matrix of odd order. So instead of odd, I'm going to give a general formula which is 2m plus 1 for that particular order, where m is equal to 0, 1, 2 and so on. So now I'll say why I gave this instead of odd number. Here you can see the m is 1, 0, 1, 2, 3 and so on, right? So first let's substitute 0 here, so that we'll get 0 plus 1. The answer will be 1, right? So 1 is a odd number, and then now let's substitute 1 here. 2 into 1 we'll get 2, 2 plus 1 it will be 3, which is again an odd number. Similarly, we are substituting 2 in the place of m, so we'll get 2 into 2 which is 4 plus 1 we'll get 5, right? So this is also an odd number. So instead of odd number, I'm writing a general term called 2m plus 1. And now we know that determinant of A is not equal to 0 because A is a non-singular matrix. Therefore, we can write that determinant of A is not equal to 0, right? Now we have to check whether determinant of adjoint A is positive, right? We have to prove that. For finding this, we have a formula in theorem 1.9, which I have given in my previous video. I will send that link in my description box so you can go check it out. So the formula for determinant of adjoint A is determinant of A power n minus 1. Okay, so here n is nothing but our order, so we have taken our order as 2m plus 1, right? So let's substitute that here, so that we'll get determinant of A power, in the place of n we are going to substitute 2m plus 1. So let's substitute here 2m plus 1, and here there is a minus 1, let's substitute here. Okay, now we'll get determinant of A 2 power 2m, here plus 1 and minus 1 will be 0, and we'll get this where m is equal to 0, 1, 2 and so on. So we get this, right? So here you can see determinant of adjoint, we have to prove that determinant of adjoint A is positive. For that, let's see 2 into m. Now we are substituting a 1 in the place of m, so that we'll get A square, which is even number, and then we are substituting 2 here, so 2 into 2 it's a 4 and it's an even number. And here I'm substituting in the place of determinant of A, just I'm guessing it, I'm substituting minus 1 here, and I'm substituting 1 here, so minus 1 the whole square will be 1, which is a positive number. And then I'm substituting some minus 2 here, so minus 2 into 2 into in the place of m I'm substituting any 2 here, so that we'll get minus 2 power 4. So the answer will be 16, which is a positive number. So you can see that this particular determinant of A power 2m is positive. So whatever we substitute in the place of determinant of A, we get a positive number. So therefore you can say that determinant of adjoint of A is positive. So this is what we have to prove. Therefore we have proved it. Then you can write it as hence proved. Okay. Example 1.5. Find the matrix A if adjoint of A is equal to 7, 7, minus 1, 11, 7, 11, 5, 7. So here they have given the value of adjoint A, and we have to find the value of A here. And now the formula for finding A is plus or minus 1 divided by root of adjoint A, which means determinant of adjoint A into adjoint of adjoint A. So this is the formula for finding the value of A through adjoint A. Okay, now let's first find the determinant of adjoint of A. So determinant of adjoint A is equal to, we have to put this value in the determinant symbol. And now let's find the determinant for this. For that, first you have to take the first element and then write it. Then you have to cancel both horizontal and vertical values of that element, so that you'll get 11, 7, 5, 7. Okay, now you have to cross multiply it, so that 7 into 11 you'll get 77, and you have to put a minus in here, and 7 5s are 35. Right, and next you have to put a minus sign because you have to use an alternative pattern while finding the determinant of some matrix. And the second number is another 7, so we are putting a 7 here, and then you are cancelling both horizontal and vertical values of 7, so that you'll get minus 1, 7, 11 and 7. And now you are going to cross multiply it, so that you'll get minus 1 into 7 will get minus 7, and you have to put a minus sign here, and then 7 into 11 you will get 77, and then you are going to put a plus sign because you have to put the sign in a random manner, which is plus, minus and plus. And the third value is minus 7, so we are putting a minus 7 here. So minus into plus, it will be a minus, so we are putting a minus symbol here. And then to cancel both horizontal and vertical values of minus 7, so that you'll get minus 1, 11, 11, 5. Now let's cross multiply it, so that we'll get minus 1 into 5 will get minus 5, and you have to put a minus sign here, and 11 into 11 will get 121. Okay, so now let's solve this. 7 into 77 minus 35 will get 42, and then minus 7, and minus 7 minus 77 will get minus 84, and then minus 7 into minus 5 minus 121 will get minus 126, and after multiplying and subtracting this, we will get an answer 1764. Right, so this is our value of adjoint of A. And then next thing we have to find is adjoint of A. Right, so what we have to do, we have to find the adjoint of this particular matrix. For finding adjoint of A, first thing you have to do is the pattern of sign, which is first thing there will be a plus sign and then a minus sign and then a plus sign, right? So first let's put a plus sign and then take the first value, which is 7, and you have to cancel both horizontal and vertical values of that 7, so that you'll get 11, 7, 5 and 7. And now you have to cross multiply that, so that 11 into 7 it will be a 77, and then you have to put a minus sign here, and then 7 into 5 will get 35. Okay, so and then the next thing, it will be a minus term. Next is 7, and you have to cancel both horizontal and vertical values of 7, so that you'll get minus 1, 7, 11 and 7. And minus 1, now you have to cross multiply it, so that you'll get minus 1 into 7, you'll get minus 7, and then you have to put a minus sign here, and then 11 into 7 you'll get 77, and then it will be again a plus sign here. The third value is minus 7, and you have to cancel both horizontal and vertical values of minus 7, so that you'll get minus 1, 11, 11 and 5. Now let's multiply, and similarly you have to find the values for other elements. After multiplying, let's solve this. Here 77 minus 35, it's 42, and then minus 7 minus 77 will get 84, minus 42 and then 84. So after subtracting and solving this, we'll get an answer this, and final step is to make a transpose. For making the transpose, you have to take a column and put it in a row. So 42, 84 and minus 126, you have to put it in a row, minus 126, and then next second row, you have to take the second row and put it in a second column, which is minus 84, 126 and 42. and then final row, and you take it as the final row and put it in a column. 126 minus 42 and 84. So this is how you'll find the transposes here, and therefore we have found the value of adjoint A. Now let's substitute in the formula of A here. The formula of A is plus or minus 1 divided by a root of determinant of adjoint A. So we have found that as 1764, and then adjoint into adjoint of A, which is our this term. So we have to substitute this here. And now you can see that 42 is common in every element. Here 42 ones are 42, here 42 twos are 84, and 42 threes are 126, and similarly the same numbers are repeated, right? So therefore 42 is common in every element, so we are going to take 42 outside. So therefore we'll get plus or minus 42 divided by root of 1764 is nothing but of 42, right? Now let's solve this. We'll get 42 ones are 42, 42 twos are minus 84, and 42 threes are 126, and 42 twos are 84, 42 threes are 126, and 42 ones are 42, and then here 42 threes are 126, and 42 ones are 42, and then finally 42 twos are 84. So therefore let's cancel these two, 42 and 42. So therefore our answer will be A is equal to plus or minus 1 minus 2 3, 2 3 minus 1, and minus 3 1 and 2. So this is our answer. So they have given a matrix adjoint A, and we have to find the matrix A, and therefore we have found the matrix A here. So that's it for this video, guys. Thank you guys. Thank you so much for watching. If you enjoyed this video, please hit the like button and make sure to subscribe. See you in the next video. Bye.